about networking 2.0 and how to network everything, people, entities, and things. So I want you to start here with imagining for a moment. Imagine it's the future, a little bit in the future, and you're driving your car to work. It's 9 o'clock, and all of a sudden your car starts talking to you. It's your personal AI, and it says, "Hey, it's 9 a.m. You haven't had your coffee yet. Would you like a coffee?" And you think to yourself, "Hell yeah, I want a coffee." But you think, "I wonder if Jen could meet me for a coffee." So you say back to your AI, "Hey, yeah, I'd love the coffee, but I wonder if Jen could make it." And you wait a minute or two, and your AI gets back to you and says, "Hey, Jen can make it, and would you like me to take over driving?" "Hey, yeah, that'll be great. Take me driving." So you arrive at the coffee shop. Jen's there. Your coffee's on the side. They know exactly what you want, and you sit down with Jen, and you have your chat. You have your coffee. Life's good. I said this is in the future. What's a little scary is the AI world knows how to do this. They know exactly how to do this. We're already seeing it. It's not that far into the future. But we're networking folks here, right? Can you imagine making that work with today's IP network? Can you imagine phoning up and raising a change control to open the firewall port for that AI to speak to this thing? There's no way on earth that's ever going to work. We have a problem, Houston. So when I think about that, this is what I think about. Freaking nightmare. We have a choice. We're at a crossroads. We need to be able to network AIs for sure. And that's the future where you can say, yeah, this AI talks to another AI that talks to me, that talks to my device, talks to my car. And we need another level of abstraction. The other way of doing it, frankly, is some mega corporation decides to do it all in the back end. And if they're doing it in the back end, they can see everything we do, they can monitor everything we do, and they can start influencing us even more than they're influencing us right now. So to get to the utopia rather than the dystopian future, we need to do things differently. We need networking 2.0. So that's what we've been working on. My name's Colin Constable. I've been in networking and security for 40 years now, which is rather shocking. Started at BT, went to Credit Suisse, Juniper Networks, Deutsche Bank, and 4 years ago started up Atsign to solve this problem. And we believe we solved it, but we haven't solved everything. We need your help. We're an open source project, and we'd like to get you guys involved. What we've done is build a protocol. We're network folks. We built a protocol to do this, not an API. Why? Because whoever owns the API owns your data. To hell with that. We need to have a protocol where we can have keys at the edge where people own their own keys, entities own their own keys, AIs even own their own keys. They can talk to each other end-to-end encrypted. The way to do that really simply is to write a new protocol and give new addresses. So an address on our protocol is no different than anything else. It's just what we call an @sign. It's just a unique string of characters. Mine is @Colin. So if you can ask me anything you'd like. My answer is always going to be @Colin, and then you can look up that detail with with my @sign. You can look it up. So that's an address, and you can look up anything. You can exchange data end-to-end encrypted because everything's private. Everything's private because you cut your own cryptographic key, not some other company cut it. The other thing that's ridiculously important is when somebody asks you a question, you need to know who's asking the question before you can give an answer. So if somebody says, "Hey, what's your location, Colin?" I need to know who you are before I'm going to give you an answer. So if my wife says, "What's your location, Colin?" the answer is my office. Now, she can imagine what that is. It doesn't really matter. If Bob Wachowski over there asks me, "What's your location, Colin?" I can give him the exact details of the public house that I'm at in London so he can come join me. Context matters, and it needs to be built into the protocols. So that's what we've done. So you're probably asking, well, so what? What does this change? Well, if you imagine back to that coffee story, if you can make all the actors nodes on the network at a high level, and then your network is just how you join those together, then we've got a network at a higher level of abstraction that makes things so much easier. But how does it work under the skin? Well, this is how it works. You cut your own keys on your device. You have a replica of that data in the cloud in a microservice. But importantly, that microservice, although it's exposed to the internet, all the data in that microservice is cut with keys it never has. It never has the keys. Only the person, entity, or thing you want to share data with has the keys to decrypt it. This means we solve client-server. Clients never speak to a server. The server never gets to see your data. Only clients speak to clients, and clients have their own encryption keys. So we have end-to-end encryption through the SDK and the protocol working together. So again, so what? Well, if you imagine all those actors having this sort of setup, if you can design the network where all these actors to talk to each other, because all connectivity is outbound, there are no ports exposed at the IP layer, there is no risk of some data getting out of control because it's always encrypted with keys that the internet presence hasn't got. You can join these things together and know that it's going to work on the network. You know full well it's going to work on the network because we're just doing really simple things. So what does this change? Well, it changes everything. This is the first time in IP land we've ever had an abstraction layer where we can do anything and know that somebody in the NOC's not going to say, hey, you can't open that firewall pool. So I'll give you a quick example. So I come from banking, so it's going to be a banking example. So if I want to pay, Colin wants to pay Anthony at $200, I can say to BOA, my bank, I want to pay Anthony $200. BOA can speak to Anthony and say, hey, Colin wants to give you $200. Which account number do you want in? At that point, Anthony can say, you know what, I don't want any money from Colin, to hell with that. And maybe never give an account number. Or give the account number a Chase, and then BOA can put money into Chase. All this stuff, you can describe the story. You can do this now on the network layer. You don't need to have any pain or agony trying to get this in the network layer. If you can describe one of these diagrams, you can make it happen on the network layer. We have an abstraction layer. So what does that mean? Well, it means that you can use it in any use case. It could be air travel. It could be chronic disease management. It could be agriculture, retail, smart cities, fleet management, critical research, supply chain management, restaurants, mining, hospitality. You imagine it, we can do it. It's a big, big, big change. I'm going to give you an example. We're network folks here. I hope everybody knows what SSH is. I chose SSH because if you drop a single bit, it will drop you like a stone. It's great. So if we had Constable wants to log into a box called @SSH1, we decide a rendezvous point. We meet that at a rendezvous point called @stream. That's a TCP connection. And we get 2 ports for that. I send them up my SSH to the rendezvous service. It sends its SSHD to the rendezvous service. Boom, we've got the connectivity behind 2 NATs. And it's sort of near perfect security. There's a little bit more detail, obviously. Come see us and I'll show you the detail. This is the detail diagram. Let's show you it really happening. Here we go. So I'm logged in on my internet. It says IPA. You can see I really am on the internet. This is the SSH command I'm running, and you can see concept, SSH1, IoT devices, and name of the machine. Boom, we're in. Look at the IP address on this machine. And we'll see it's a 192.168. So we jumped across a NAT boundary. Now we're going to use Nmap. This is a port scanner to see what ports are open on that IP address. Normally, you'd expect to see 22 open on that IP address because how else are you going to get to it? So let's Nmap that and see what we get. No ports open. So we've SSH remote into the machine anywhere in the world. As long as it can see the internet, you can SSH into it. And it has no attack service. Not managing attack services. We're talking no attack services. We support all these environments. We're an open source project. We need your help. Throw some sticks at it. Please get involved with us. Come chat with us. We'll show you the detail. We'll even show you that demo up and running. My @sign really is @Colin. You can go to wavy.ng @Colin and book a meeting. Come talk to us. Thank you so much for your time. If you've got any questions, don't speak to me here. Speak to me at the booth just over there. Thank you so much. And I think we're on time. 36 slides in 9 minutes. Yes. Good job. Thank you so much.